Welcome to the short presentation of SDTagNet, leveraging text-annotated navigation maps for online HD map construction. This work focuses on the problem of online HD map construction in autonomous driving, where you want to detect road information such as road borders or lanes online to avoid having to rely on pre-processed offline HD maps. In online HD map construction, it is natural and already done to use navigation maps or SD maps such as OpenStreetMap to enhance the detection accuracy. But existing methods that do this are quite limited in the information that they use that we have available in SD maps. For example, if we look at the rightmost image at the bottom, we can see we have varied element types such as nodes, polylines, and relational information. And each element also has a set of quite detailed textual annotations that contain, for example, the number of lanes, whether this is a one-way road, the width of the road, etc. And this information is not really used at the moment. You either have, in the case of PMapNet, a rasterized top view image where you just have this is a road or this is not a road, or in the case of Smurf, a set of polylines, but only polylines and with a limited number of manually defined classes. And SDTagNet is the first work that enables open vocabulary textual annotations and diverse element types for SD maps. For the architecture overview, we have on the top row our standard online HD map construction pipeline, where we take a set of camera images, fuse them into one joint bird's eye view feature grid, and then use these bird's eye view features in a transformer decoder that outputs the predicted map elements. With SDTagNet, we now also have a set of tag polylines or general SD map elements, where we first use a lightweight BERT encoder to generate tag set embeddings, one for each element, and then use these tag set embeddings in a SD map encoder to create SD map tokens, which we then supply to the main transformer via cross-attention. Some key ideas of SDTagNet are: we have a custom self-supervised NLP pre-training procedure for the BERT encoder using contrastive learning. This is needed because standard pre-trained encoders do not perform well on the highly specific nature of OpenStreetMap text annotations. And also we have a flexible query design using orthonormal element identifier vectors from the field of graph transformers that allows us to represent points, polylines, and relational features all as standard transformer tokens usable by a standard transformer architecture. All of these changes result in a 45% MAP gain versus having no prior, and even a 20% MAP gain versus methods that already use SD-map priors. For a qualitative comparison, I have here an example where we have a one-way road in the ground truth. SDTagNet is able to correctly detect this one-way road based on the textual annotation in the SD map, while the other approaches simply hallucinate a standard two-way crossing topology here instead. In another example, we have a road in front of us with 6 lanes. Here again, SDTagNet is able to correctly deduce the number of lanes based from the textual annotations, and other approaches hallucinate some different non-existing topology. If you are interested in more details, you can check out the paper or the code using the QR codes provided below, and I would be happy to meet you in person at the NeurIPS.